Welcome to Lecture 0, overview of Networks, Friends, Money, and Bytes. This course is about networks, social, economic, and technological networks that show up everywhere, such as the Facebook network, where a node is a Facebook user and a link is a friendship relationship on Facebook, like the Wikipedia network, where a node is a Wikipedia article and a link is a hyperlink between the two web pages. And they live on top of the internet, which is a network of networks. And you can think of it, for example, as a connected set of routers with a lot of functionalities running on top of it. And they lead to what's called overlay networks. For example, end users and some servers forming a more structured topology on top of the underlaid internet in peer-to-peer networks, such as BitTorrent. And there are also physical infrastructure behind the network, such as the access networks, the fiber, copper, and wireless networks. In wireless case, you have a coverage map like this, which is a particular 3G coverage map in United States. And the network live on top of the spectrum. That's the underlying resource, which is you can think of that as the air that the signals use to be transmitted. So this course is a selection of some of the practical questions regarding these networks. I'm going to do a quick preview. And as in any preview, you're not supposed to understand what's coming up next. We're going to use one picture to illustrate each of the 7 lectures in this short course coming up. And this is just to give you a sense of the kind of questions we'll be formulating and answering in this course. I'm going to start with the 3G cellular network. For example, here are a lot of cells, and in each cell there might be a base station, and there might be different mobile stations, such as your cell phones or tablets, talking back and forth with the base station. There are a lot of powerful ideas about networks behind cellular networks, going from the first generation to second generation to 3G, and these days to the 4th generation, for example, LTE networks. And we will in particular talk about the idea of tragedy of commons, as all these transceivers utilize the same common resource, a particular set of spectrum. How do we take care of their interference? And in explaining a particular way to do that, called power control, we will illustrate the essential idea in optimization and in game theories, which will be useful throughout the course. Then we'll switch to very different kinds of networks, even though the underlying mathematics turns out to be remarkably similar, and that is the Google PageRank algorithm in ranking web pages. So think of, say, 4 web pages here, and they are connected with some directional links. For example, if we label these as 4 web pages, and page 2 points to page 3 because it has a hyperlink linking to page 3, but not the other way around. Okay, so this is a connected, but with direction of the connections network. And in this network, we would like to understand which of these 4 nodes is the most important. How do we even define the notion of importance of a node in a graph? And how do we use those importance metrics to help rank the web pages that each time you search on Google determines the order of their appearance? Now that is ranking a lot of objects in a network with one single result. Sometimes you want different results for different people. For example, if you have 6 subscribers to the Netflix service, or in your country maybe another kind of video streaming or DVD rental service, and the company, say Netflix, would like to understand which one out of, say, 8 movies it should recommend to a given user. For example, you are user number 5 here. Well, Netflix knows how did you rate your prior watching experience with movies 1 and 6. Say you rated 3 stars out of 5 for both. And the question is, what likely will be the number that you would give as the rating to movies 3 and 5? And Netflix may pick the one with a higher number, to recommend to you. Now, this is a recommender system, and it tries to leverage the network effect among the users and among the movies to provide a more accurate prediction. And along this process, we'll also introduce more on optimization theory and also machine learning theory. Now, turning from social to economic networks, we'll address a very important question these days. A lot of the mobile operators around the world, including the major ones in the United States, are leaving the unlimited buffet mobile data plan and going to charge you based on usage, for example, $10 per gigabyte. Now, why is that? We're going to look at the imbalance between demand and supply per dollar of investment over time. We're going to look at some utility and demand function models that will help us to understand the reasons why certain pricing information and feedback is provided to the customers to change their consumption behavior. Now, all these networks actually live on top of the internet. So what is the internet? It's a network of networks, and there are very powerful ideas behind it, including the idea of packet switching, the idea of modularization. For example, 5 functional modules shown here in this layering diagram, and the idea of distributed coordination and hierarchy. We'll introduce these powerful concepts, and then we'll zoom in to one of these functional modules called the network layer to look at how routing is done in a semi-distributed way on the internet. And this will lead us further into another kind of distributed algorithm, controlling the allocation of resources. In this case, not the air, but the bandwidth across the end-to-end connection of the internet. We're going to see how distributed sources, such as your laptops and desktops, can coordinate with each other without explicit coordination, relying only on implicit quote-unquote pricing feedback signals sent from the networks and the links, so as to avoid the internet collapsing under congestion. And finally, we'll take a look at another kind of tragedy of commons, in this case, a much tougher spot to do coordination compared to 3G or TCP/IP. In this case, it is Wi-Fi, and we'll see very smart ideas and their utility and limitation in doing distributed coordination over a network. And try to understand why, for example, Wi-Fi is often slower at hotspots compared to their speed at home.